Yeah, what's up, folks? Welcome back to another video. Aye. This one's gonna be a fun one. I've had lots of fun doing it. Okay, so in today's video, we're gonna be basically proving the 5 kinematic equations. Okay, so let's get started. Okay, so the first equation we're gonna be proving is V is equal to AT, u plus AT. This is the first equation we're going to be proving. Velocity is equal to initial velocity plus acceleration times time. Okay, to understand this, let's take a velocity time graph. Okay, let me just erase these previous markings I made. Well, too bad, I'm not able to erase this. But you know what's the starting point on a velocity time graph? What's this? Aha, what was my question? What's that? It's a starting point. So that is your starting point. So that is your u variable. So this is your u. Okay, that's your u. And what's this? Well, that's your final. So that's your v. This entire thing is your v variable. You know, u is the initial velocity, v is the final velocity. That's initial velocity, that's final velocity. So basically, from here, if you take this u, put it here, it's this u plus this random something value that's equal to your velocity, right? It's this u plus this value that's equal to velocity. Okay, easy. So with understanding this, it's u plus something. Let's go and construct this. Let's go and write, v is equal to u plus something. Okay, v is equal to u plus something. Now, how do we find that something, right? Yeah, to find that something, we're going to use something very obvious. Something like relating to the line. Slope. Always it's centered around the slope. We're going to use the slope of the line. Okay, so let's find the gradient of the line. Let's find the gradient of the slope. Well, the gradient is what? Rise over run. Rise on run. What's this rise on run here? Well, the rise is v and the run is the time. So the rise is my bad. What's the rise on run? The rise on run is equal to the acceleration. What was I explaining to you guys? What is the slope in a velocity time graph? Remember from our previous video that the slope of a velocity time graph is the acceleration. Okay, so the acceleration is equal to rise over run. We don't know our rise yet because our rise is v. So we do not know it. We want to find this part. But we do know our bottom is the time. So it's t. So a is equal to rise on t, and then easy. What's rise? Rise is equal to at. Nice. We found a variable. Our rise is equal to the acceleration times the time. Simple. So now that we know that, we can go in here and fill in that something for the at. V is equal to u plus at. And voila. We have proved the first one. Graphically that too. Have fun. I don't think you've been exposed to graphically, proving it. I wasn't exposed to this in our school's curriculum. This is just fun. It's interesting. Okay, now let's look at the algebraic proof. What is the algebraic proof? The algebraic proof goes like this. Acceleration is equal to v minus u on t. Okay, then you're just rearranging it because you know the acceleration normal form is v minus u over t. That's the basic one we're all told to memorize. Then you just rearrange and find v. Solve for v. Okay? Simple. So that's our first one, proved algebraically and graphically. Let's go to our second kinematic equation. Uli. Na. I only watched Salah yesterday. It was a fire movie. Okay. Okay, let's look at, proving u plus v over 2 times t. That's displacement. Let's look at proving that. Okay, so in a graphical sense, where did I disappear? No, bad boy. Yeah, okay. So in a graphical sense, this is our line. Okay, so this is our acceleration, because why? It's velocity time graph. But we want to do something different this time. This is u, v, we are in the same situation, time. So let's find the area under the graph. Okay, let's find the area under the graph now. Simple. Find the area under the graph. So the area under this graph, this shape looks like a trapezoid. Okay, so if you flip it over, it's going to look like a trapezoid, right? So just keep looking at this in the top, and then just flip it. The u goes to the top, the v goes to the bottom, the time goes to the side. So it's a trapezoid, and we know the area for a trapezoid, right? The area of a trapezoid is basically the length L1. Area of the trapezoid is L1 plus L2 over 2 multiplied by the height. Okay, so let's fill in whatever we know. Let's fill in whatever we know. We know that L1 and L2 is u plus v over 2 multiplied by time. And voila, we've explained our stuff already. S is equal to u plus v over 2 t. Simple. Because where did displacement come from? Remember, what is area under the graph? Area under graph is displacement. So displacement S is equal to, that's what you're solving. You thought we were solving for area. Yeah, area. What's the area? Displacement. So S is displacement. Oh, my bad. I do have an error on my side. I forgot the vector symbol. But displacement is equal to u plus v over 2 times t. And now let's go on to solve this algebraically. Algebraically, right? It's very simple. We're taking the average velocity formula, which is speed over time, because what's average speed? What's average velocity? It's distance over time. And take this, average velocity is also u plus v over 2. No, I know it's a lot to process in, but let me explain it to you step by step. What's this u, what's this v? You're probably wondering. Okay, so calm down while my app is being glitchy ass. Okay. Oi, stop. Okay, let's explain. So, algebraically, right, we know the average velocity is equal to speed over time. But then, if the velocity is going in a constant, if it's constantly average, right, then we know that our initial velocity plus our final velocity over 2 is also our average velocity, right? So let's equate them. U plus v on 2 is equal to speed on time. Now, cross multiply, u plus vt is equal to 2s. Then, just simplify s. S is equal to u plus v over 2t. Simple. That's our second kinematic equation. Write down the notes if you want to. Now, a third one's a bit interesting. It's going to involve us remembering number 1 and number 2. So, how do we solve for the third one? Just give me a second while I rearrange this. The third one, right? Graphically, we want to be proving this. S distance or like displacement is equal to ut plus half at squared. Well, we're going to be using the same methodology, finding the area under the graph. So velocity time graph, what's the area under the graph? Displacement. Paka. That's why we're equating our final one S as displacement. So our velocity, our time, this is at u, this is at time, this is at at. Yeah. This is important. You know how we know this entire thing? is v. This entire rise is velocity. It's a final velocity, right? This is the final velocity, right? So this is at because we found it in the start. It's acceleration times time, which is u here. So this is at. This segment here is at. So now we're just going to segment it off. That's why the color coding. We're going to find the area under the graph. Because this is like this kind of velocity, we're going to find the area here and then the area here. Sure, we can use the trapezoid method, but we want to equate this to something else, so we're going to be using this method. So we're going to cut it off and let's find it now. So what's this one here? Well, u times t, ut. So the area for this rectangle is ut. So that's why under the rectangle part, we got ut. What's the area of a triangle? So the area of a triangle is half base, which is t, times at. What's this? It's basically half at squared. And that's what we have here as 0.5 at squared, half at squared. So let's add them both together now, because that's what we're doing. That's how we find the total displacement, right? That's how we find the total area. So your displacement is equal to ut plus half at squared. And that's second one proved graphically. It's just so much fun proving these graphically. It just makes so much sense, right? Now let's looking at doing it algebraically. Doing it algebraically, this way I kept it as a third equation. In your books, this would usually be your second one, or it doesn't matter, guys. Come on. But we're gonna add equation 1 and kinematic equation 2 algebraically to get a third one. And why is this? Well, we're doing this to eliminate the v. You know how the first one was v is equal to u plus a t, if I'm right. Isn't that the first one? U plus at. Yeah, v is equal to u plus at. And then our second one is equal to s is equal to s is equal to u plus v on 2t, right? So basically we're adding these both together to eliminate it. So what we want to do is find t here. So take the first one and find t just by itself. No, my bad. It's in v format already. Right? No. All we're doing is we're using this. We're using the second one and we're substituting one into this. Sorry, I had it wrong. We're basically substituting the 1 into the 2. Alrighty? That's simple. Okay. So let's go and simplify it. Let's go and substitute, let's write equation 2 more clearly now. S is equal to u plus v on 2 times t. So what's v again? We know v to be u plus at. So speed is equal to u plus, what's v? V is equal to u plus at. U plus at whole thing over 2 times t. Okay, so what's this? We know this u plus u is equal to 2u plus at. So that's 2u plus at all over. Don't. Come on. Yeah, u plus u2 over 2 times t. So that is displacement. 2u plus at over 2 times t. Now, when you simplify that down, the 2 and 2 cancel out. That's u plus half at squared because you're multiplying the t. So, yeah, that's u plus half at squared. So that is your final answer. Alright. Now, having looked at 3 of these graphically already, let's look at the fourth one graphically too. So, the fourth one, well, it's basically rearranging the first equation. So, the first one was a is equal to v minus u over t. You're basically rearranging to find t. So, t is equal to v minus u over t over a. T is equal to u minus v over a. And then you're using this to substitute into equation 3, which you just found, which is u plus half a t squared. So substitute t in there, folks. Substitute it for 3. So u plus half a, what's t squared? Well, you know the t square is equal to u minus v over a. Just substitute that in. Half a into u minus v into a. So when you do that, guys, you actually end up getting this. Go ahead and simplify, and you'll get v squared is equal to u squared plus 2as. That's it. Thank you for watching. Have a great day. That's the end of the motion line series. Have fun.